Hey, so we're starting a new unit. This is trig identities and solving trig equations. Um, on a word of note, this. Um, yeah, you definitely need to know all of these. You definitely need to know these, but remember we also talked about the rewritten forms of these. So it's great if you know that sine squared plus cosine squared equals 1. But you're also going to have to know that sine squared equals 1 minus cosine squared, because I subtract cosine squared from both sides. Or if you subtract sine squared from both sides, the cosine squared theta equals 1 minus sine squared theta. Yeah? So you need those. You also need, notice that there are 3 different Pythagoreans here. And you need to know each of those, like you need to know that 1 plus tangent squared is equal to secant squared. But if you subtract 1 from both sides, you determine that tangent squared is secant squared minus 1. And if you subtract tangent squared from both sides, that 1 equals secant squared theta minus tangent squared theta. And that's kind of interesting because both of these are equal to 1, so sine squared plus cosine squared is actually also equal to secant squared plus tangent squared. I'm sorry, minus tangent squared. Good, and then don't forget, if instead of dividing this equation by cosine everywhere, cosine everywhere? Yeah, cosine everywhere. What if we divided by sine squared everywhere? We would then have 1 plus cotangent squared equals cosecant squared. And we want the rewritten versions of that as well. So we want cotangent squared equals cosecant squared minus 1, and 1 equals cosecant squared minus cotangent squared. So you definitely need to know all of those, and I believe you'll see that on your identities form. In this first part of the unit where we're working with trig identities, and yeah, we're going to be verifying and proving certain identities are so. And in the second half of this unit, we're going to be working on solving trig equations. And there are definitely going to be some trig equations that require us to be comfortable with all these trig identities, which is why we're going to spend a couple of days here working on trig identities. And to that end, I know we have the 3 magic secrets of trigonometry: draw a triangle, know your unit circle values, know your trig identities. Yeah. I kind of want to throw in something for the part of the unit that we're starting now. And that something that I want to throw in is a strategies list. Do you remember 2-column proofs? Do you remember feeling like you were kind of lost and you could put down the given and you know this was the thing you were trying to prove? But other than that, you often felt like, I don't know where they're getting this stuff from. Well, the same kind of thing happens to some students in this next stuff we're going to work on. Verifying trig identities is the main focus of it. And I think rather than have that sort of sad, vacant, 2-column proof horror flashback, that instead we'll have a strategies list. And the thing about the strategies list is when you get stuck, go down the strategies list, yeah, and try each of those things, or ask in your head why, is this when I want to use this, or when I want to use this other thing. I truly find that students who actively engage with the strategies list that we will be developing in this video and in the next couple that students who actively engage in using that list, as opposed to saying, "Yeah, I got a list somewhere, but I don't know what the hell it is." Yeah, those students probably aren't going to do well, and they need to ask a lot more questions. But you, this should not be you. You should be comfortable with this because you are going to engage in your identities. Okay, so let's take a look here. Yeah. Um, so we're told to, for these first few problems, match the trig expression to one of these. And we're given some choices. We're told that A is secant x, B is -1, C is cotangent x, D is 1, E is negative tangent, and F is sin x. Okay? So we're going to look at some problems, and we're going to see which of them simplify to which of these letters. Okay, so our first one is secant x cosine x. Okay, so what can I do with secant x cosine x? Well, I know from my reciprocal identities that secant x is 1 over cosine x. Oh, and cosines cancel, and I'm left with 1. So this problem, D. All right, how about this one? Cotangent squared theta minus cosecant squared theta. What can we simplify that with? Well, you know, there's a bunch of things we can do. This is sort of tempting to say, hey, didn't we just talk a moment ago about cosecant squared being 1 plus cotangent squared? And that cosecant squared, you know, if we subtract cotangent squared from both sides, we get 1. Well, isn't that this? And the answer is no. It's close, but no, it's not this. That's got a negative cotangent squared, and it's positive cotangent squared. That's got a cosecant squared, and it's got a minus cosecant squared. Well, what I could do over here is I could say, all right, well, let's factor out a -1. And we're going to have negative cosecant squared, and here we're going to have plus cotangent squared, and equals 1. Well, this is that stuff. So I'm going to divide both sides of the equation by -1, and I'm going to have this stuff equals 1 over -1, which is -1. Oh, look, that's choice B. Now, that method of doing this problem, yeah, most students don't do that because, well, that's horrible that I have to factor in the middle of that thing. And what more students do is they say, well, I remember the cosecant squared is 1 plus cotangent squared, so I'm going to plug that in there. So cotangent squared theta minus, now, not this, but all of this stuff, 1 plus cotangent squared theta. Cool. Distribute that negative. You get cotangent squared theta minus 1 minus cotangent squared theta. Hey, look, these cancel, and we're left with -1. So we've got choice B for this one. So, yeah, what I want to say is there are lots of different approaches to simplifying these things. There's some students who, when they see something like this, what they want to do is say that's cosine squared over sine squared minus 1 over sine squared. And then they say, oh, look, I've got a common denominator. I can write that as cosine squared minus 1 over sine squared theta. And here, gosh, cosine squared minus 1, wasn't that one of our Pythagorean identities? No, it was 1 minus cosine squared equals sine squared. But we've got cosine squared minus 1. All the signs are opposite. I guess we could factor out a -1 here. I would have -1 plus cosine squared theta cosine squared theta. And if I divide both sides by -1, I'm going to get that this stuff is here. And so I can replace the numerator with negative sine squared. And so that I've got negative sine squared over sine squared, and I'm left with -1 again. I mean, I really do deeply appreciate the opportunity to have different ways to do the problem. This is definitely a little more forgiving that way. All right, let's take a look here at this one. You know, I will say with this one, I'm less likely to be the person asking you questions that involve these identities. For these identities, I really need to use the even and odd function notes that I have. Okay, so I know that cosine is even, which means that the cosine of -x equals the cosine of x. And we talked about that in a prior video. So I'm going to change this to be that. And we know that sine is an odd function, which tells us that if we have sine of -x, that's going to be equal to negative sine of positive x. So I'm going to replace this, this sine of -x, with negative sine of x. Well, we know from our quotient identities that sine over cosine is tangent. And don't lose that minus sign. Okay? But again, I'm not likely to be asking you about this. I don't think Mr. Paz is going to reach into the even and odd problems. But, you know, I think fair game on something like ACT. Okay, next. How about this one? Oh, and I'm not trying to match anymore, by the way. I'm just sort of going to simplify. Sometimes we talk about rewrite these expressions. So cosine beta times tangent beta. And here I sort of want to start us on our strategies list. One strategy is rewrite in terms of sine and cosine. Okay, so I'm going to get rid of, this is fine because it already is a cosine, but tangent, I'm going to rewrite that tangent as sine beta over cosine beta. And while I might not have understood what this was equal to or how to simplify this expression, here I see I can cancel out those cosines and I'm left with sine beta. And that's all they're asking me to do here, simplify this expression until I get here. Now, I want to say some things about it. Simplify. First is one term is more simplified than 2. And the second thing I want to say about simplifying is one term is better than 2. Oh, and no, what's the other one? Yeah, it's not coming to me, but I'll get it out there soon. I myself find this assignment and the next one a little frustrating because I don't know if I've simplified enough or the right way sometimes. And I want to say, look, don't worry about that because when we get to day 3, they're going to start telling us, oh, this is equal to sine beta, and they're just going to ask us to show how this stuff turns into it. And so eventually they'll tell us what our answer should look like, but while we're starting, we're just really thinking about simplifying. One term is more simplified than 2. Yeah, it's not coming back to me, so I guess we're just going to have to do some problems until I find what that other one was. And we'll continue to add to our strategies list. These two things are just for section 5.1, simplify. One term is more simplified than two, and I think it's not fraction is better than fraction. So if I've been given, for example, sine over cosine, well, nice, but not a fraction is better than a fraction. Let's go with that for now. Can't wait to add things to our strategies list. I have a strategies list here. It's got 9 things on it. And not only will you have those 9 things soon on your strategies list, but you should, in fact, when you're stuck, always go to your strategies list. Okay, secant squared theta, 1 minus sine squared theta. Okay, so what do you got here? Well, isn't that interesting? There's a bunch of different approaches here, huh? So, some students want to use this, rewrite in terms of sine and cosine. Hey, I want to say something about rewriting things in terms of sine and cosine. Like, it is a really powerful strategy for beginners. You can get a lot of mileage out of it. But by the time we get to day 3 and day 4 of this stuff, people who are still using this one, they're actually making the problem much, much longer and harder. So, yes, it's good to know how to use it. It's good to embrace it. We can certainly do this now. Secant squared is 1 over cosine squared. And now what? Well, some students go this way. And now they've got cosine squared minus cosine squared sine squared. No, they don't. These are in the denominator. 1 over cosine squared minus sine squared over cosine squared. Okay, but 1 term is more simplified than 2. So I see a common denominator here. I guess I can write that as 1 minus sine squared over cosine squared. Hey, I was there already. Huh. So maybe we want to take a look at strategy number 2, use an identity. If you don't know your identities, it's unlikely that you'll be able to use your identities. Which is why, even though you have this identities handout in Teams, and I think it's great if you're using that identities handout today, but by the time you get to day 3, and certainly by the time you get to day 4 in this unit, yeah, no identity sheet should be out. And on your assessment, yeah, no identity sheet will be given. When you take any placement test or essay, no, you're not going to have an identity sheet. So you have to know them. I have seen colleagues allow their students to use identity sheets. Yeah, and then they fail all the tests and quizzes because guess what? They say, well, I don't have to learn this. It's just on the identity sheet. I'll find it there. Yeah, no. Sorry, 30 years of teaching math tells me, no, it's really unlikely that you're going to find what you need to find because it's not already in your head. You're staring at a piece of paper, hoping to see something that makes sense because you didn't practice enough. So you need to get those identities in your head. You need to practice this until you say, oh yeah, I can do this. 1 minus sine squared, that's cosine squared, over cosine squared. Okay, fraction, let's go further. Not a fraction is better than a fraction. So I get 1 here. Cool. So this was one way to do the problem. Actually, it was 2 different ways. Like we did this, and we did the distributing thing, and then we said, oh, look, a common denominator, and that was actually just that, with the denominator pulled off to the side. And so I kind of want to go back here and say, hey, if I'm using my identities, use an identity. If I'm using my identities, what's 1 minus sine squared? 1 minus sine squared is cosine squared. And we know secant squared is 1 over cosine squared. And so they cancel. And I go 1. And I'm all done. Okay? Now, again, some people say, well, Mr. Guru, are you done? Well, I'm done because one term is better than two terms, and not a fraction is better than a fraction. And I can't get any more simplified than that. Now, it doesn't mean that there aren't things that I could replace this with, like 1. Well, 1 is equal to tangent. 1 is equal to secant squared minus tangent squared. But yeah, that's, to me, that's much more complicated than that. So I'm not gonna go further. Okay, use an identity. Good thing to know. Of course, I'm gonna have a real challenge with that if I don't know my identities. So please really know your identities. How about this one? Cosecant theta over secant theta. What would you recommend here? I agree. Both of these could work. I could rewrite this in terms of sines and cosines. So that's going to be 1 over sine theta over 1 over cosine theta. Yeah, this has a lot of mileage. This is really good on day 1 into day 2. Days 3 and 4, it's useful, but I probably wouldn't lead with it, especially on day 4. So where do we go next? Well, I got a fraction over a fraction. Why don't I do flip and multiply? 1 over sine theta times cosine theta over 1. That's going to give me cosine theta over sine theta. And what is cosine divided by sine? That's cotangent theta. And I think that's about as simplified as I can get this. All right. Yeah, we used our reciprocal identities, and then we flipped and multiplied. This could also be thought of as rewriting in terms of sines and cosines. Okay, next. 1 over tangent squared theta plus 1. Okay. Well, I could rewrite this in terms of sines and cosines, but I don't think that's going to make this easier. But let's do it. Let's see what happens. This is going to be 1 over sine squared theta over cosine squared theta plus 1. Well, I need to make a common denominator if I'm going to add these two, because one thing is better than 2. I'm going to multiply by cosine squared over cosine squared. Okay, so where does that bring me? Well, that brings me to sine squared plus cosine squared over cosine squared. Cool. Hey, don't be that kid. That's pool nibble. If you can't take it out of all three, no, don't even try and do that. Cosine squared theta. Instead, use an identity. You know, if you haven't been practicing these, you may not notice that sine squared plus cosine squared is 1. And so now we've got 1 over cosine squared, and according to our reciprocal identities, 1 over cosine squared will be secant squared. And there's my simplified version. Now, oops. Oh, isn't that interesting? 1. Oh, this is all in the denominator. Not bad. Okay. So I have 1 over all this stuff. 1 over, and we had sine squared plus cosine squared over cosine squared. Okay, sine squared plus cosine squared is 1. And so now I'm going to do a flip and multiply. So I'm going to have 1, that's this one here, times flip and multiply. Cosine squared over 1. And so I end up with cosine squared. Good. That's one approach to this problem. I don't like that approach to this problem. I think it's long. I think you can get there, but I wouldn't do it. Instead, I know my identities, and I know 1 plus tangent squared is secant squared. And I know that 1 over secant squared is cosine squared, and so I'm done. There are lots of ways to do these problems. Some of them are inefficient, and some of them are efficient. And here's what I can't tell you. I can't tell you, not because I don't want it, but just because I really don't know. And I can't tell you by looking at this initial thing what the sequence of strategies will be that is always the fastest one. You can certainly explore that. We'd love to have some thoughts on that topic, but I don't have anything like that. Instead, I have a strategies list. And first, we're saying rewrite in terms of sine and cosine. And 2, use your identities. Okay, still got 7 more things to add to this list. Let's see if we can find some of them. Tangent squared over secant squared. Well, it may be helpful. And this was another thing middle school math was trying to get you ready for. It may be helpful to rewrite this fraction as 1 over secant squared times tangent squared. Yeah, so 3/4 in middle school was 1/4 times 3, or 3 times 1/4. All of these are the same. And maybe you want to have this as a strategy. That idea that you can, shift these. Yeah, it won't be one of my 9 strategies, but I worked with a student last year who had 15 strategies on her list because, this was a new thing for her brain. So respect what's new for your brain. If this is like, wow, I never would have thought to do that, you might want to. Because 1 over secant squared, we know is cosine squared. And if I rewrite this in terms of sines and cosines, I get sine squared over cosine squared. Oh, and look. And so now I'm left with sine squared. Not a fraction is better than a fraction, is what I say. Okay, so we've got a bunch of examples here of using these 2 strategies. There are some co-function identities. We talked about these briefly. I know that sine of theta is the same as cosine of pi over 2 minus theta. Yeah, sorry. I'm just not, this is not distributing, by the way. Do you recognize that? Pi over 2 minus theta? Yeah, most people don't. That's the supplement. So, I'm sorry, the complement. And what did we say? We said complements of co-functions are the same. And there's that thing that we got in the trig basics unit. But sometimes these show up like cotangent pi over 2 minus x times cosine x. Well, that's a co-function identity. So look at my identities list and say, oh, well, that's the same as tangent times cosine. And tangent, well, I could call that sine over cosine. And those will cancel, and I'm left with sine. Yeah, I'm going to minimize the amount that you're going to have to interact with co-function identities. I mean, I think they're good to see. I think it's good to have that reminder that, yeah, that sine graph really is just the cosine graph that's been shifted and reflected. We saw that on the first day of graphing, that one was just the reflection of the other. In fact, we could have said, hey, if I take my sine graph and apply these transformations, I'm going to get that cosine graph. And that's always true. Okay, but yeah, no, I don't think you'll see much of this for us. Okay, next. How about this one? Cosine t times 1 plus tangent squared t. Okay, so, there's two ways to do this problem. One is to recognize that 1 plus tangent squared is what? It's one of your identities. That's secant squared. Okay, and we still have times cosine t. Cool. Well, I know from the reciprocal identities that secant squared is 1 over cosine squared times cosine. I can cancel out 1 with 1. That gives me 1 over cosine, which is secant. Oops, not secant theta, secant t. Oh, see how I've been writing the angle? Yeah, some students like to do this. And I've told Mr. Paz, every time the student leaves off the angle, minus 1, minus 1, minus 1, minus 1, minus 1, yeah? It's not cos. Cos is a type of lettuce. It's not tan, right? It's cosine of an angle. We need to have a representation of that angle there. Otherwise, I don't know what you're talking about. I think you're talking about strange English things. Okay, so we're looking at cosine t equal times 1 plus tangent squared t. So the first time we went through and did this problem, we used our identities and called that secant squared. And then we wrote secant squared as 1 over cosine squared, so we can cancel that cosine. Well, I'd like to use a different strategy now. I'd like to distribute. And in fact, strategy number 3, distribute or FOIL. And I guess its inverse, factor, are 2 more things to add to our list. Now, I don't know if it's going to make sense to do that here. We've got times 1 plus tangent squared t. Now, I distribute, and I get cosine t plus cosine t tangent squared t. And now, well, I'm not going to factor, because if I factor, that's just bringing you back where I was, right? I could take a cosine out of both of these, and I'd be left with cosine divided by cosine is 1 plus, and then I took out the cosine, so I have that tangent squared. Yeah, so generally, if I'm going to distribute, I'm not going to follow that up with factoring unless I'm saying, yeah, no, let's go back to where we were. So what am I going to do here? Well, I think if I rewrite this in terms of sines and cosines, maybe that'll help me get somewhere. So tangent squared is sine squared, sine squared t over cosine squared t. And I can cancel that with that. But now I've got cosine t plus sine squared t over cosine t. And I could break this up into sine t times sine t over cosine t. I'm not gonna, but you could. And this idea of splitting up this fraction, that's another one of those strategies that's not one of my 9, but is sometimes really helpful. And it's not on my 9 because my brain knows this already. If your brain doesn't know this, like, when I say no, I don't mean just like, yeah, I took a class with that guy 3 years ago, but I really don't know anything else about it. You don't know that guy. It's my brain knows this means, oh yeah, I know what that guy I took that class with a couple of years. He's a really good buddy of mine. I know, in fact, what his favorite birthday present is. And if you're not on favorite birthday present with this kind of thing, you might want to write this down as another strategy. Yeah? Okay, so what can I do here? Well, yeah, I guess that could be tangent. And then I would have cosine plus sine times tangent. But I don't know what to do with that. And students say, well, why don't I just write sine over cosine as tangent? But you just went that direction, so I don't think I would do that. So that's all kind of problematic and challenging. But what I can say here is, no, we're not stuck We just need another strategy. 5. Hey, look, I've got two things. One thing is more simplified than two things. And so, how about we make a common denominator? Its inverse is split one fraction into two fractions. So if I had 1 plus cosine over sine, I could split that into 1 over sine plus cosine over sine. That's this strategy. This is strategy number 4, where I want to take something that is one term and split it up into two different terms. I know our goal is to say one term is more simplified than two, but sometimes, in order to get to the promised land, we're going to have to split one fraction into two. But in fact, that's not our problem right now. Our problem is this one. And I say, let's make a common denominator. So this has a cosine on the bottom, and this one doesn't. So this needs a cosine over a cosine. Cool. Don't cancel those cosines out. It's really embarrassing because you just multiply top and bottom by cosine to make the common denominator. Instead, you should say that cosine times cosine is cosine squared plus sine squared all over cosine 2. Cool? Now, tell me about this numerator. What's that equal to? Cosine squared plus sine squared, that's 1. If I know my identities, I recognize that as 1. If I don't, I should probably get some flashcards going. And then 1 over cosine is secant. And that's another way to do this problem. So we have options. We have alternatives. And I encourage you, if you're not sure your alternative works, ask about it. Ask about whether it worked here or whether, no, don't do that, that's terrible, or whether that's really freaking brilliant, and I'm proud of you for going that way. Into 2. So we've got 5 strategies now. Let's see what the next one is. Cosecant phi tangent phi plus secant phi. Mr. Google, why do you keep changing that angle? In the last problem it was t, and then before that it was beta, and before that it was theta, and then it was x, and why? And the answer is, do you have only one color of socks? And the answer is no, of course you don't. Look, sometimes we get tired of writing theta or x, so we'll pick another Greek letter. It's all good. You could even do some sort of little picture of a tree for each of these, but I'll tell you that the little picture of the tree will make your math homework take a lot longer. So I recommend something like x or theta, or if you're getting tired of writing x's and thetas, how about a phi or even a lambda? All right, so what can we do here? We've got cosecant times tangent plus secant. Which of these strategies looks good to you? I don't see fractions to make a common denominator. At least not yet, I don't. I don't know any identities with these except reciprocal identities, and maybe here the quotient identity. Okay, we could do that. There's no factoring that I see, and I definitely don't see any foiling or distributing. So like I said, when you get stuck, like I don't even know how to start this problem, well, that's when you start looking at the strategies. Hey, could I rewrite this in terms of sine and cosine? Sure, I can rewrite those in terms of sine and cosine. Oh, identities. This is 1 over sine. This is sine over cosine. This is 1 over cosine. I could do both of those. Distributing, I don't see any distributing here. There's no this times these two things. I don't see any foiling here. I don't see any fractions here to make a common denominator. Split one fraction into 2. I don't even have one fraction yet. And I don't see any factoring I can do. So let's use one of these. So cosecant can be now 1 over sine. Tangent is sine over cosine plus 1 over cosine. What do you notice? Me too. And so now I have 1 over cosine plus 1 over cosine. Well, that's going to be 2 over cosine. And remember, 1 over cosine is secant. So this is going to simplify to 2 secant, phi. Please don't change the angle in the middle of the problem. If you start with a little tree, finish with a little tree. If you're going to start with phi, finish with phi. And that's my simplified version. Okay? Okay, strategies list. Rewrite in terms of sine and cosine. To use an identity. 3 was FOIL distribute. 4 factor. That's the undoing of this one. 5, we said make a common denominator. This is something I'm going to do when I'm looking to turn 2 things into 1. And instead of things, let's say fractions. And of course, its inverse, split 1 fraction into 2. So, if you have something like sine theta plus cosine theta over cosine theta, you can split that into 2 fractions, sine theta over cosine theta plus cosine theta over cosine theta. And that'll be tangent, and that'll be 1, you get tangent plus 1. But what you can't do is this. Cosine theta on the top, sine theta plus cosine theta on the bottom. This does not split. Okay? 2 things, 2 or more things on top, I can split the fraction up. 2 or more things on the bottom, no, I can't split that up. So don't even try. Okay? All right. Let's see if we can go through a couple more of these. Now that you've written down your strategies list, and we'll keep adding to it, I'm not going to have the strategies list. I'm merely going to say to you, start reading your strategies list. Go through each one at a time and say, can I use that here? All right, so next, sine theta secant theta plus cosine theta times cosecant theta. So I'd like to find a way to simplify this. I know that secant is 1 over cosine. And I know that cosecant is 1 over sine. So I guess I could write this as sine theta over cosine theta plus cosine theta over sine theta. And yes, it's very tempting to say, oh, that's tangent plus cotangent. And stop there. Tangent theta plus cotangent theta. Yeah, I want to keep going. And here's why. This is 2 things. And while, it could be that my answer is those 2 things, I see here 2 fractions. And I know that 1 fraction is more simplified than 2. So let's make a common denominator here. This gets multiplied by sine over sine. This gets multiplied by cosine over cosine. And so now I have sine times sine, which is sine squared. Cosine times cosine is cosine squared. And on the bottom, our common denominator, sine times cosine. Well, what's that? Yes, I agree, that's 1. Sine squared plus cosine squared is 1. And we've got 1 over sine. Change the angle, and cosine. Well, this can be rewritten as 1 over sine times 1 over cosine. 1 over sine is cosecant, 1 over cosine is secant. So now I've got 2 different ways to simplify this, and they're not coming up with the same thing. There's this one, And where's the other one? This one. Okay. And so, Mr. Google, I'm confused. They're different. Yeah, they are. And that's one of the reasons why I said the first couple of days in this unit, the big challenge is knowing, was that okay? Is that okay? And what I would say is, yes, these are both simplifications. I will say, as a guiding principle, that one thing, right? It's one term, thing times thing, one term, is better than two terms. Terms joined with addition and subtraction. These are two terms. This is one term. Okay? But you should ask Mr. Foz what he thinks. He's going to be the one grading that work. Okay, and really, when you get into day 3 and day 4 of this, you're not going to have that trauma about, my God, this doesn't look like everybody else's. Because you're going to be told at the beginning of the problem what the answer should look like. All right? Okay, how about this one? Sine squared x cosecant squared x minus sine squared x. Okay, so what are you thinking about doing? Did you hear that? People said two very different things. Ooh, let's do the problem two different ways then. I heard some people saying cosecant squared, that's 1 over sine squared. And so they write sine squared x times 1 over sine squared x minus sine squared x. And then look here, these cancel, and I get 1 minus sine squared. And I know that 1 minus sine squared is cosine squared. And I feel pretty good about that. That's what I heard some students saying. They wanted to use that reciprocal identity. Oh, just a note. So it is true that that cosecant is 1 over sine, and that cosecant squared is 1 over sine squared. That works great. Here's what doesn't work. Sine squared does sine squared, oh yeah, plus cosine squared equals 1. Some students think then that this must be true. Like if I can square both of these so this works, can't I take the square root of these to make this work? And the answer is no, absolutely not. And so how can I explain that? Well, it's easy. Here, I'm squaring both sides of the equation. That's what gives me this. Can I take the square root of each piece, or do I have to take the square root of the whole side of the equation? This is wrong. I can't do that. That's not possible. So, while it is true that sine squared plus cosine squared equals 1, sine plus cosine almost never equals 1. Equals 1. No. And let's think about that for a moment. Let's pick a sine for an angle and a cosine for an angle. So an ordered pair on our graph. Like at pi over 6. The ordered pair is root 3 over 2, comma 1 half. So if I take 1 half plus root 3 over 2, do I get 1? No, I don't. I get 1 plus root 3 all over 2. Well, that's not 1. Exactly. That's why this does not work, or that's how I know that this does not work. Okay, I can't take the square root of each piece. I can only take the square root of the whole side of the equation. Okay, but all of that has just been about that student. Hold on, there's more. Hey, so some students said, whoa, these both have a sine squared. So they factor a sine squared out. And they have cosecant squared minus 1. Remember, sine squared divided by sine squared is not 0. Sine squared divided by sine squared is that 1. That 1 better show up there. Otherwise, I'm not going to recognize this. Cosecant squared minus 1, sure, that's cotangent squared. And now, I can say, well, sine squared times cotangent squared will be cosine squared over sine squared. These cancel, and I get me to cosine squared again. So lots of different ways to do this problem. I encourage you to try different paths as long as your brain and time permits. So yeah, factoring. Factoring is on our list. Distribute and FOIL, but also undoing distributing and foiling by factoring. It's another item on our strategies list. Okay, so how about this one? Secant to the fourth minus tangent to the fourth. Well, that's a difference of squares. There are two things that we learned last semester that we need this semester, and one of them is factoring, and the other is solving. You know, where I set the factors equal to 0. So yeah, difference of squares. This is going to be secant squared x minus tangent squared x times secant squared x plus tangent squared x. Okay, do you recognize that as one of your identities? It is, and you do need to recognize that secant squared minus tangent squared is 1. Now, yeah, no, I don't have that. I have secant squared minus tangent squared, not secant squared plus tangent squared. You could do a couple of things here. Some students say, well, wait a minute, Mr. Kukla, isn't secant squared the same as 1 plus tangent squared? And so then you could turn this into 1 plus 2 tangent squared. That's one approach, okay? Or, because now we only have one trig function. One trig function is better than two different trig functions. Well, what if instead of getting rid of secant squared, I said, hey, tangent squared, isn't that secant squared minus 1? Sure is. I know my Pythagorean identities. Secant squared plus secant squared is 2 secant squared minus 1. And that's perfect. One trig function better than two trig functions. That's fine. And again, don't stress about this, because on day 3, we're going to start telling you what the answer is supposed to look like. Okay? So we're going to know what the answer looks like. Yeah, we're just simplifying. Okay, last thing is, and these students usually, you know, they're gonna make a commitment to rewriting everything in terms of sine and cosine, and sometimes that is wunderbar, sometimes that is sehr schön, but sometimes it's a lot of extra work. So I've got this common denominator, I noticed, so I could write 1 plus sine squared over cosine squared. And 1 plus sine squared, hey, isn't that cosine squared? And that's 1. Wait a minute. Huh? How can that be 1? Well, guess what? 1 plus sine squared is not cosine squared. And that's one of those things where, like, you know, people who have a casual relationship with their identities, it's not going to help them. It's 1 minus sine squared that is equal to cosine squared. The original identity is sine squared plus cosine squared. So to get cosine squared by itself, I have to subtract the sine squared. 1 minus sine squared, yeah, that's cosine squared, but that's 1 plus sine squared. No, that's not cosine squared. So what could I do from here? Yeah, well, here's the thing. The only thing I think to do here is to go back the way I came. I guess if I didn't want to split one fraction into 2, I could do something like this. Hey, sine squared. Isn't sine squared equal to 1 minus cosine squared? Sure. So, oops, cosine squared. So I'm replacing this with this, all over cosine squared. So we've got 1 plus 1, that's 2 minus cosine squared over cosine squared. Cosine squared. No, you can't cancel those out because this doesn't have any. I guess you could write 2 over cosine squared minus cosine squared divided by cosine squared is 1. And 2 cosine squared, hey, isn't that 2 secant squared? Yeah, and we saw this answer 5 minutes ago. So, yes, I can factor, and you definitely have to recognize that difference of squares. Woof. Okay, how about this one? How about cosine squared minus 4 over cosine minus 2? Oh goodness, please don't cancel 4 and 2, and don't cancel a cosine. You can only do that if you had cosine squared x times 4 over 2 times cosine x. Because then you've got this one term on top and this one term on the bottom. But that's not what we have. You know, here, yes, I can do that. But that's not this. This has two terms on the top and two terms on the bottom. And the only way you can do the canceling like this is if you could factor the same thing out of the top and out of the bottom and cancel them. We can do that. That doesn't mean there's nothing to do, though. There's factoring there. That's a difference of squares. That's going to factor as cosine minus 2, cosine plus 2, all over cosine minus 2. Hey, look. And there's an answer. Okay? That's not this one. That's this one. So, factoring is your friend. Please, make it be your friend. Don't have it be the sworn enemy who comes in the night and slits your throat with a rusty dagger. That's always a sad way to wake up. Okay, how about these last two? Secant to the third minus secant squared minus secant plus 1. 4 terms. Guess what? I want to factor by grouping. Yep, all those nifty factoring techniques that we learned last semester or reviewed last semester, fair game here. Factor by grouping. See that? Make sure you catch it inside that parenthesis. Every student who doesn't put that minus inside that parenthesis gets this problem wrong, and I don't want that to be you. Okay, GCF factoring. I got secant x minus 1. And here, I could take out a negative 1. I've got secant x minus 1. So, look, let's factor out a secant x minus 1. And what are we left with? We're left with this and that. Secant squared minus 1? Yes. Very good. Tangent squared. Secant minus 1, isn't that tangent? No. No, it is not. This works. That does not work. This is not tangent. Secant x minus 1. There. That's as far as I can get. I guess I could turn these into sines and cosines. I don't think it's going to get me any further, but I hear that some of you would like to see that. So this is 1 over cosine minus 1, and all of that is times sine squared over cosine squared. Okay, how about I make a common denominator here? So this is cosine over cosine. Cool. So I've got 1 minus cosine on top, and on the bottom I've got the cosine times a sine squared over a cosine squared. Well, cosine times cosine squared, I guess I can write that just as cosine to the third. And on top, the only thing I see to do here is to distribute. I guess I could turn that into 1 minus cosine squared. It's not going to be pleasant. 1 minus cosine squared. And so now I could FOIL 1 minus cosine squared plus cosine to the third over cosine to the third. Hey, and you know, I could actually split this up into 4 different fractions. 1 over cosine to the third minus cosine over cosine to the third minus cosine squared over cosine to the third plus cosine to the third over cosine to the third. And what's that going to do? Well, let's see what happens. 1 over cosine to the third is secant to the third And here I've got a cancel with a cancel, and I've got minus secant squared. I can cancel both of these with two of those, and so I have minus secant, and here I have plus 1. And that's where we started, which is why I really like the third unit in this video that tells me what it should look like when I'm done, because wow, I ended up making a really big circle there. So remember when we had gotten to this point, tangent squared x times secant x minus 1? Yeah, I'd stop there. Stop. Okay? Okay. Well, oh, how about just this last one? Just this last one. Tangent to the fourth plus 2 tangent squared plus 1. Okay, that's a trinomial. In fact, it's a perfect square trinomial. It's going to factor as tangent squared, 1 and 1. And since this is positive and this is positive, both of those are positive. Hey, what's tangent squared plus 1? Secant squared. Hey, what's tangent squared plus 1? Yup, secant squared. And so secant squared times secant squared, not secant squared plus secant squared. Secant squared times secant squared is secant to the fourth. And we're all done. If this had been a plus symbol, we would say secant squared plus secant squared is 2 secant squared. But that's not our problem here. Our problem is multiplication. These are multiplied together. All right. Well, welcome to our new unit. I like to think that you have some sense as to where we're headed and what we're doing with this, because we've got some more of it to do. I'll see you in the next video.